Good morning. Nanomaterials. In this section, we will discuss about the nanomaterials. So, how to synthesize the nanomaterials and what are the different type of the nanomaterials and the carbon nanotubes. First of all, we will discuss about what is mean nanomaterial. So, any material having at least any one dimension in the range of 1 to 100 nanometer is called nanomaterials. Suppose you will take it now one sheet of the paper. Its thickness is about 1 lakhs nanometers. Now the 1 crore rupees. This is the macroparticles. We consider it now 1 crore rupees compared to the 1 rupees. So 1 rupees is 10 to the power of 8 times expanded. We get it now the 1 crore. The same dimension is applied in the nanoparticles. One of the example of the nanoparticle is the fluorine. Its dimension is 10 nanometers. So it is expanded around 10 power 8 times. We get at now 1 centimeter diameter balls, steel balls. So the fluorine is the nanoparticle, ball is the macroparticles. So the same way 1 rupees in the case of the 1 crore, the same dimension is applied the macro and the nano scales. So nanomaterials may be like metals, alloys, intermetallics and ceramics. In general, nanomaterials exhibits a greatly altered properties such as physical, chemical, mechanical compared to the bulk of the same materials. So we'll take it now the different form of the nanomaterials. So first we take it now the nano sheet or nano well. This is the two-dimensional. So any one dimension must be in nanometer scale or nanoscales. So you take it now this is the rectangular sheet. Its x-axis length is the macro value and breadth is also macro value, but the thickness in the nanoscales. So same way we take it now the circular disc. The radius of the circular disc is the macro scale, but thickness is the nanoscales. So any one dimension in nanometer means the particle is called as nano sheet or nano well. Next one is the nano rods or nano wires. So any two dimension must be in nanometer scales. So in this case, we take it now along the x-axis is the macro scale, y this is the thickness, and z this is the breadth value. These two values are nanoscales. So the x value is the macro scales. At the same way, we take it now the radius of the cylinder is the nanoscale and length of the cylinder is the macro scale, means this is called as nano rod or nano wires. Next one is the zero dimension, the nano dot or quantum dot. In this case, along the x-axis, y-axis and z-axis, all values are in the nanoscales. Suppose you take it to the sphere, means its radius is the nanoscale value. So it is not have any one macro scale value. So the all values are in the nanoscale. So this is called as the zero dimensions. Another one form of the nanoparticle is the fullerenes. In the case of the fullerenes, its sphere, the nano spheres, its radius is the nanoscale. So nearly 60 carbon atoms are arranged in a spherical structure which contain 12 pentagons and 20 hexagons. So these are the general properties of the nanomaterials. The grain size, control the mechanical, electrical, optical and semiconducting, magnetic and chemical properties. The change in the size, its properties are completely changed. It has more brittle optical properties, melting point, magnetization, magnetic moment value. All values are completely altered compared to the macro particles. So synthesis method. The synthesis process of nanomaterials classified in two types. One is called the bottom-up process and another one is the top-down process. First of all, what is meant by bottom-up process? So in this case, we take it now any one of the atom. It is built of atom by atom and get the nano size. Top-down process. So in the case of the top-down process, the bulk material is broken into nano size. So first case we take it to the bulk material, it is around centimeter scale. So 10 to the power minus 2 meter. It is broken into the microparticle. Its dimension is now 10 to the power minus 6 meter. Then it is reduced its size. We get to know the nanoparticle. Example is the ball milling methods. The ball milling method. This is the solid cylinder. So the solid materials are filled inside. So the macroparticles are filled inside and rotate the drum. We get at another nanoparticles. These solid materials are collide one by one. The particle is lies between these two, so its size will be reduced. So this is the steel drum. These are the hard disk materials. These are the bulk materials. These are the nanoparticles. Another one is the mechanical crushing method. In this case, two solid cylinders are fixed in a very small gap. So the bulk materials are placed at here, so rotating in the opposite direction, clockwise and anti-clockwise. So the macroparticle is enter in the small region, so it is broken into small piece. We get into the nanoparticles. This is also one of the oldest method to produce the nanoparticles. Another one is the chemical vapor deposition. So in this case, we take it to the one closed chamber. This is the gas inlet, and this is the tube pump is connected. So excess gas is removed from this tube channel. This is the substrate. So first case we take it now. One XCl2 filled in the chamber. So next we take it now. One hydrogen atom is added in the chamber. So after this hydrogen atom is interact with the XCl2, so the Cl2 atom is come out separate from the X materials. So then the hydrogen atom is interact with the Cl chlorine atom. So we get that now HCl. Then it is come out from the chamber. Material is placed on the substrate, so we get at now very small thin films are these are called as nanofilm. This is the one type of the synthesis of the nanoparticles. So another one is the pulsar laser deposition method. In this case we get at now the one laser source. This is the substrate, this is the target material. Suppose the laser beam is falling on the target, so the atoms are gain some energy and is escape from the solid space and it is deposited on the substrate. After a few times, we get at now the nano sheets are occupied in the substrate surface. This is the one type of the another one type of the laser deposition methods. So nanotube, a single sheet of the carbon sheet is atoms are arranged in a hexagonal lattice pattern is called graphene. Suppose the graphene sheet is rotated. The carbon nanotube is cylindrical rolled up of graphene mostly closed at the end. So these two end is joined and we get at now the closed shape. This is called as nanotube. The categories of the carbon nanotube, it is classified in two types. One is called the single walled, another one is multi-walled or double walled. So they have only one sheet is rotate form the cylindrical shape. Here one more sheet is make the cylindrical shape. So it is covered based on the axis. So this is called as double walled nanotubes. Carbon nanotubes are categorized based on the structure as armature, zigzag and chiral. Suppose we take it now one graphene sheet, it will make it now along the x-axis. So this along the x-axis we make the joining the upper and the lower surface. We get at now the armature carbon nanotube. Suppose we will take it now along the y-axis. At now we join these two ends. We get at now the zigzag method nanotube. Suppose lies between x and the y-axis, any one of the angle, we make these two parts are joined with each other. We get at now these are the chiral nanotubes. The electrical properties of the carbon nanotubes depends on the hexagons oriented along the axis. Suppose in the case of the armature, the axis hexagon axis are linked parallel to the axis of the carbon tubes. So hexagons oriented the circle around the carbon nanotube configures labeled zigzag method. Suppose this do not form any line that are called chiral. So this is the armature case. In the case of the armature, look like the shape of the armature at their edges. So this edge point of shape is the armchair. So this is called as armchair structures. So in this case, the hexagon is parallel to the axis of the carbon nanotube. It is act as the good conducting materials. Another one is the zigzag method. In this case, the structure is around the axis. Okay, and we get it to the zigzag shape in the upper side. So this is called as a zigzag method, and it is act as the semiconducting material. Last one is the spiral or helical structure. In this case, the structure is not have any specified structure. So this is called as helical. It is also act as the semiconductors. These are the reference materials. In this class, we will discuss that now. What is meant by nanoparticles or nanomaterials? What are the different form of the nanomaterials and how to synthesize the nanomaterials? Then the properties of the nanoparticles. Finally, we can discuss the carbon nanotubes. What are the different type of the carbon nanotubes? How to classify it based on the structures. Okay. If you have any query, please mail to sunphysics17@gmail.com. We will meet the next topic. Thank you.